Alam, and I did my integrated masters in applied physics from IIT Roorkee, and I have been associated with the family of askIITians for the past 4 years. Now the topic of today's discussion is modern physics. Now without laying anything about modern physics, we will first discuss in this particular video what exactly is this, what exactly is the modern physics, and what is the timeline associated with modern physics. So let's find out. Greetings students. Now let's study one of the most important topic of class 12 from both board's perspective and also from competitive exams angle, modern physics. Now before I actually tell you anything about the different phenomena or the different theories and experiments discussed in modern physics, we will first like to understand what was an outlook of science, or let's say to be precise, physics during those times. So right now when we are studying modern physics, we are actually studying somewhere between 1900 to 1950. Developments in physics in those 50 years. There was a huge, let's say a quantum jump or a big jump in the development of physics. Let's say the onset of 20th century to the mid 20th century, there was a huge jump if you compare those two landmarks. So what are the different events which took place? What were the accidents, or what were the intellectual people around those times were thinking about the nature around us? We'll study about those kind of ideas and theories in the chapter of modern physics. So first up, before going on, we should discuss what are the different topics which are to be discussed in modern physics. So first up is introduction. I'll tell you about the different things, what are the questions which were prevalent around those times. We'll discuss that in introduction and how they end up finding their answer. So we'll lay a foundation stone for the whole chapter in the introduction. Then comes the photoelectric effect, one of the most important effect, answering many questions about light, matter as a whole, and shattering one of the biggest idea, whether light is a wave or light is a matter. That is one of the strongest evidence which we have ever witnessed on the face of earth. De Broglie's idea. What was De Broglie's take on photoelectric effect? Basically, what happened is there was a quarrel between few people, a sect of people vouching for light as a wave. Then there were a few sect of people who were vouching for light as a matter. So there was a constant clash between these two sects of people. Photoelectric effect gave a help in proof that light is a matter. Young's double slit experiment gave a help in proof that light is a wave. So I have two instances or two experiments which cannot be disapproved. The result speaks for itself. So what exactly is a light? So De Broglie actually came up with his version. Now Davison-German experiment, again Davison-German experiment is an extension of De Broglie's idea. That is, these two fellas, they actually end up testing De Broglie's idea. Then we will shift our attention to three theories: plum pudding model, Rutherford's model, and Bohr's theory. So these three models are basically dealing with how an atom looks like. What are its constituents and how are they actually positioned at different places in an atom. So these three are the different theories or the famous theories which put up their own version. Then we come across one of the most useful form of light which you use in day-to-day life, that is X-rays. We'll discuss about that and why specifically I am discussing X-rays, not gamma rays or cosmic rays or UV rays. That will be discussed while we are discussing the topic of X-rays. Then we will wrap up with, or the discussion of different theories, we will wrap up with nuclear physics, how we sort of studied. Now that we have studied what an atom looks like, how it behaves, we sort of dug into a whole new level when we started studying about the nucleus. I will tell you what nucleus is, but we will discuss that first in plum pudding model, Rutherford model, and Bohr's theory. What nucleus is, what are the constituents of atom, then how a particular constituent called nucleus is used in an atom for different benefits. So we will discuss that in nuclear physics. Then finally, after all we have studied all these topics, we will sort of test our analysis or our understanding of these phenomena, these ideas, by set of few questions based on the previous year's competitive exams. So that's all which we will discuss in the chapter of modern physics. So this is a broad outlook, so watch out for more. I hope now you have understood what exactly is modern physics and what are the different aspects in the field of physics which we'll be dealing with in this particular chapter. Now, without stating the obvious and also the exciting and tremendous experiments in the field of physics which were conducted in those eras, we'll now try to find out exactly what were the key theories, the ideas predicted based on these theories. So what are those? Stay tuned for that.